Good day, everybody. How are you all doing? Today we are going to work on a sampling distribution of p hat, which is the probability distribution of p hat being the sample proportion. So let me clarify this sample proportion. And this is read as p hat. Okay. Now we will use central limit theorem. From central limit theorem, if the sample size is large, then mu p hat, which is the mean of sampling distribution of p hat, mu p hat is equal to p, which is the population proportion of success. What is success? Well, it will vary from problem to problem. Basically, it is the number of things that fall in a certain category. Okay, from central limit theorem, the sample size surge is large, then mu p hat is this. The sampling distribution of p hat is bell-shaped. Distribution of p hat is normal or bell-shaped, and sigma p hat, which is the standard deviation of the sampling distribution of p hat, standard deviation of the sampling distribution, then sigma p hat is given by square root of p times 1 minus p over n. I already identified p as the population proportion of success and n is your sample size. So, let me draw the sampling distribution of p hat. So, sampling distribution of p hat looks like this. P hat on the horizontal axis, and we have a bell-shaped curve. Remember, sampling distribution is same as probability distribution of p hat. Now its center, where the peak is the highest, is mu p hat, the mean of the population, and this is equal to p. Further, standard deviation of this curve is square root of p times 1 minus p over n. I also mentioned p is the population proportion of success. Now, they have given us some figures to get the sample proportion. Okay, so p hat is given by x over n, where x is number of success divided by sample size. So success in this case is buy a product which is environmentally friendly, Okay, so p hat, number of success. If we read the problem, 672 Americans in a random sample of 1018 buy a product that is good for the environment. So 672 is a small number out of the sample size of 1018. So we will use our calculator to estimate p hat, which is 672 divided by 1018, which is 0.6601. Okay, so this is a single point estimate of p. They did not mention what is the population proportion, so we will use this value of p hat as a single point estimate of p. Okay, next we will check. So we'll check n times p hat. N is your sample size is 1018 and p hat is 0.6601. So 1018 multiplied by multiplied by 0.6601 is 671.98, and that has to be greater equal to 10. Also, let's do n times 1 minus p hat, and that will be, we will type in the calculator as 1018 left parenthesis 1 minus 0.6601. So 1018 is our sample size, then left parenthesis 1 minus p hat is 0.6601, and that is equal to 348.02. That is also greater equal to 10. So both n times p hat and n times 1 minus p hat should be at least 10, that is greater equal to 10, so that we can assume that the sampling distribution of p hat is bell-shaped. P hat is normal. So let me change the color of my ink and then draw the sampling distribution again. Okay. First thing, before we do that, also remember our mu p hat is equal to 0.6601. Okay. We have to calculate sigma p hat, which will be in our calculator second button x square. So second button and x square gives me the square root. Inside the square root I will type the p value, which we do not know p, so we will use the sample proportion as a point estimate of p. So 0.6601 1 minus 0.6601 inside the parenthesis, okay, divided by sample size, which is 1018. So let me write that again. Sigma p hat, the formula is square root of p times 1 minus p over n. In our case, that's almost equal to p hat times 1 minus p hat divided by n. Or sigma p hat in our calculator TI-84 is second button followed by x square button, gives me the square root. Inside the square root p hat is 0.6601, left parenthesis 1 minus 0.6601 divided by 1018, which is the sample size. So let's calculate the sigma p hat value now. So first second button and then x square button gives me the square root. Inside the square root 0.6601, left parenthesis 1 minus 0.6601, that takes care of p times 1 minus p, then it has to be divided by 1018 in the denominator, all inside the square root. So that value sigma p hat is 0.014. 0.6648. So our mu p hat is 0.6601 and sigma p hat is this thing. So let's calculate because we have to deal with mu p hat plus sigma p hat. That will be equal to 0.6601 plus 0.0148, and that is equal to 0.6601 plus 0.0148, which is 0.6749. Why am I calculating this? Because we have to find the area to the right of this and the area to the left of mu p hat minus sigma p hat, which is 0.6601 minus 0.0148, which is 0.6601 minus 0.0148 is equal to 0.6453. So let me draw the picture correctly now. Okay, so this is your distribution, sampling distribution of p hat. Sampling distribution of p hat. That means p hat values are on the horizontal axis. The center is at mu p hat is 0.6601. On the right, it is a point 0.6749. On the left, one standard deviation below the mean is a point. We draw a vertical line. This value is 0.6453. So if I change the color of the pen, you will see a clear picture. So we have to find this area, probability that p hat is greater than 0.6749, and also the probability that p hat is less than 0.643. So basically we have to find the probability that p hat is greater than 0.6749 or p hat is less than 0.6453. In other words, we need to find area in the two tails or the two highlighted areas in the left tail and in the right tail. As you can see, OR means these are mutually exclusive. They do not happen at the same time. Therefore, we have to add these two probabilities. So either we can do that, but we can use another easy way. Okay, let's find the. Let's turn me back to green. Let's find the area in the center. Okay, so we know total area under the curve is 1 because sum of the probabilities is equal to 1. So area in the center is we will use our calculator to do that. We will use second button, then verse button, and select number 2, which is normal CDF. I'm starting from 0.6453. My upper boundary is, because I'm finding the area in the center, the green area, my upper is 0.6749. My mean, mu, is the population proportion represented by sample proportion, single point estimate, which is 0.6601. And my sigma, which is the standard deviation of the sampling distribution, which we found out as 0.0148. Just let me check and make sure. Yes, I'm using the correct values. Okay. So then we go to PEST and hit enter twice. This will give us the area in the center. So area in the center is the probability that p hat is between 0.6453 less than p hat less than 0.6749. Okay, and we do it this way. Second, verse 2, lower in this case is 0.6453. The upper is 0.6749. The mean is 0.6601. And the standard deviation is 0.0148. Then we go to PEST, hit enter twice. So area in the center is 0.6827. Okay, this is important. This is the area in the center. So we are supposed to find area in the two tails, the red area. So area in the two tails, which is required to find this. We are required to find this. Find this area. Find this area, which is probability in two tails. So if you look at my original picture, notice it is the area to the left of 0.6453 and to the right of 0.6749. And that will be equal to total area minus the area in the center. So total area we know is 1 minus the area in the center is 0.6827. So that is equal to 1 minus 0.6827, which is 0.3173. This is the answer to the question, what is the probability that p hat is less than mu minus sigma mu p hat minus sigma p hat, or p hat, or means they are mutually exclusive. They're not happening together. Therefore, we are adding. Because we do not know which one is happening, therefore we are adding the probability. Is equal to 0.3173. This is your final answer. Okay, let me quickly summarize what we did. First, we found out p hat, which is given by number of successes over the sample size. So p hat is 0.6601. This is a single point estimate of the population proportion. We were not given the population proportion. We need to check that n times p hat is greater or equal to 10 and n times 1 minus p hat is greater or equal to 10. If both of these are greater or equal to 10, which is true in this case, then the sampling distribution of p hat is normal. With a mean mu p hat is equal to population proportion, which we will assume equal to the sample proportion 0.6601, and we will calculate the sigma p hat, which is 0.0148. Then we want to find the area in the two tails, in the two red highlighted areas. We can do them separately, or we find the area in the center, that is between 0.6453 and 0.6749. Once we do that area in the center, from the total area under the curve, which is 1, we subtract that area in the center and we will get the area in the two tails. I'll stop here today. If you have any question or comment, write me a note. If you like this video, give me a thumbs up. I really appreciate that. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button. And please do not forget to click on the bell. That will let you know every time I upload a new video. Thanks for watching, and please do not forget to watch me tomorrow again, when I'll be back with something more interesting. Thanks for watching. Take care.